Derivative of tangent. D over dx tan x is equal to d over dx multiplied by sine x all over cosine x. So, is equal to quantity of d over dx sine x cosine x minus sine x quantity of d over dx cosine x all over cosine squared x. So, d over dx tan x is equal to cosine x cosine x minus sine x multiplied by negative sine x all over cosine squared x. So, cosine squared x plus sine squared x all over cosine squared x. Formal definition for the quotient rule. If f of x is equal to g of x all over h of x, if prime of x is equal to g prime of x multiplied by h of x minus h prime of x, g of x all over h x squared. Two trigonometric identities, sine squared x plus cosine squared x is equal to 1. Secant of x is equal to 1 over cosine x. D over dx tan x is equal to 1 over cosine squared x. The derivative of tan x is secant squared x. Example, find the derivative of y is equal to tan 5x. So the solution is we will going to use the chain rule. So f of g of x is equal to f prime of g of x times g prime of x. So y is equal to secant squared of multiplied by 5x times 5. So 5 secant squared 5x. Number 2, y is equal to tan x squared. So f of g of x is equal to f of g of x times g prime of x. So y prime is equal to secant squared x squared times 2x. So y prime is equal to 2x multiplied by secant squared x squared. The power rule of differentiation. D over dx multiplied by x to the power of n is equal to n x to the power of n minus 1. So d over dx x squared is equal to 2x squared minus 1. D over dx squared is equal to 2x to the power of 1. D over dx x squared is equal to 2x. Implicit differentiation. The technique of implicit differentiation allows you to find the derivative of y with respect to x without having to solve the given equation for y. Example, find dy over dx if y is equal to sine x cosine y. So, dy over dx is equal to cosine x minus sine y dy dx. dy dx multiplied by 1 plus sine y is equal to cosine x. So, dy over dx is equal to cosine x all over 1 plus sine y.